Hello student. Today we are going to study the most important topic of the class 11th, that is moment of inertia. See, in moment of inertia, what we'll do is that we'll be calculating the moment of inertia of ring, rod and disc. See, what we'll do is that moment of inertia of ring. See how the moment of inertia is calculated in the case of ring. See, suppose we have a ring. This is having radius r. See, what we do is that we take the small element over here. Let us suppose the mass of the ring is how much? Mass is m, and the circumference will be the length. It is equivalent to what? This is 2 pi r. So what we do is that we'll take out a small elementary element. Mass of the small elementary element. What is that? Mass of elementary element. What is that? See, what we have? Mass per unit length is what? 2 pi r. Let us suppose there is a small length. This is delta x. So mass of the elementary element will be what? Delta x. And this is what? Delta m. And we know that moment of inertia is what? Moment of inertia is basically I. This is delta m into r square over here. See what we have? This is m, this is 2 pi r, this is delta x, this is r square, and we have to integrate. What we have done, we have taken this part, small delta, we have to calculate the for the whole radii. So see the whole circumference to be precise. See, this is 2 pi r. See what we'll get. What we do is that we'll take out m r square over here. This is 2 pi r. Integration of delta x, and it goes from 0 to 2 pi r is how much? See, this is m r square. This is 2 pi r. And this is what? Integration of delta x is what? X. It goes from 0 to 2 pi r. So what it becomes? This is m r square. This is 2 pi r. This is 2 pi r minus 0. So what we get? The moment of inertia of the ring is going to be mr square. See, we'll go for 2-3 cases. What is that? That moment of inertia about any diameter. Moment of inertia of ring about any diameter. See what is that? See what we'll do, we'll apply the perpendicular theorem, perpendicular axis theorem. This is id plus id is what? The moment of inertia of the ring is mr square. So moment of inertia along any diameter will be equivalent to mr square upon 2. Then we'll go for the moment of inertia of ring about tangent which is parallel to the plane of ring. See, let us suppose this is the ring. This is what is the topic is moment of inertia about tangent parallel to plane of ring. See what in this case what we do, we will take, let us suppose this is CD, this is what AB. We have to calculate the moment of inertia along the CD, and that is what? Moment of inertia along AB plus applying parallel axis theorem. See what we get. See what is this is one of the diameter, so it is going to be what? mr square by 2, and this is m, this is h is what? Distance between new axis and old axis. That is mr square. So what we get? This is 3 by 2 mr square. Then what we'll do? Moment of inertia about tangent which is perpendicular to the plane of ring. In this case what we'll do is that, see this is AB, this is CD. The topic is moment of inertia about tangent perpendicular to plane of ring. See in this case what we'll do is that again we'll apply the parallel axis theorem, moment of inertia along the CD is what? Moment of inertia along the AB plus mh square. So what we have? Moment of inertia of ring is mr square, and this is m. Distance is again r, so it is going to be mr square. This is 2mr square. This is the moment of inertia of ring which passes through the center mass. Then we have moment of inertia about any diameter. Then we have moment of inertia about tangent, which is parallel to the plane of ring. And this is moment of inertia about tangent, which is perpendicular to the plane of ring. Now we'll go for moment of inertia of disc. See, we'll go for moment of inertia of disc. See, in this case, let us suppose topic is moment of inertia of disc. See, disc having a radius r. See, what we'll do in this case is that we'll take out elementary ring over here. Let us suppose we make a ring over here. So mass of this elementary ring, see, this is having a elementary ring has a radius of x, and let us suppose calculate the mass of the elementary ring. See, mass of disc is how much? This is m, radius is r, so area of disc will be how much? Pi r square. So mass per unit area will be equivalent to m upon pi r square. So what we are doing is that find mass of elementary ring. See what it will be. It will be what we have. This is suppose we take out this ring. The length will be what? 2 pi x, and the width is what? Delta x. So our area is 2 pi x into delta x. This is the area of this elementary ring. Now we'll go for the mass of elementary ring is how much? See what we have. This is mass per unit area is how much? This is m upon pi r square, and the ring which we are concerned with is 2 pi x into delta x. So what we will do is that we'll go for the moment of inertia, that is basically equal to what? Delta m. This is basically delta m. This is delta m into x square, and what we'll do is that we'll integrate from 0 to r. So what we have? This is m, this is pi r square, this is what? 2 pi x, this part into delta x. Again what we have? This is x square. So what we have? This is, we can cancel this out. What we have? This is m, this is r square, this is what? 2, this is x cube delta x, and it has to be integrated from 0 to r. See what will happen over here? This is 2m, this is r square, this is what? X to the power 4 upon 4. It goes from 0 to r. So what will happen over here? This is 2m, this is r square over here, this is what? R to the power 4 upon 4. So what it becomes? It becomes mr square by 2. This is the moment of inertia of disc. Now we'll go for the few cases related to it, that is moment of inertia of disc about any diameter. See, again we'll apply the perpendicular axis theorem, that is moment of inertia along the any diameter. Let us suppose it is y-axis, this is x-axis, then id plus id. We'll get the moment of inertia along the z-axis, that is mr square by 2. So this is mr square by 2. This is what? 2id, or we can write mr square divided by 4. This is the moment of inertia of disc about any diameter. Now we'll go for like moment of inertia of disc. Inertia of disc tangent to the plane of disc. Moment of inertia of disc about tangent parallel to plane of disc. See, let us suppose this is CD, this is again, let us suppose any diameter, one of the diameter. Let us suppose we have to calculate the moment of inertia along the CD. That will be equivalent to what? Moment of inertia along the AB plus mh square. We know the moment of inertia, this is moment of inertia about any diameter. So what it will be? This is mr square by 4 plus this is m, h is what? R. This is mr square. So this is going to be what? 5 by 4 m r square. Now what we can go for? Moment of inertia about tangent, which is perpendicular to the plane of disk. This is disk. Moment of inertia about tangent perpendicular to the plane of disk. This is our CD. This is our AB. Moment of inertia about tangent which is perpendicular to plane of disk. See, in this case what we'll do is that moment of inertia along the CD will be equivalent to moment of inertia along the AB plus mh square. So what we have? The moment of inertia about center of mass is mr square by 2. This is mr square. So what we get is that moment of inertia is 3 by 2 mr square. This is moment of inertia about tangent which is perpendicular to the plane of disk. Now what we'll go for? We'll calculate the moment of inertia of rod which passes through the center of mass. We'll calculate moment of inertia of rod which passes through center of mass. Pass through center of mass. See, let us suppose we have, this is the rod. It has length L and mass M. So this is the axis. So distance over here to here will be L by 2. Because our topic is moment of inertia which passes the center of mass. So it is rotating about this mass. Then let us suppose a small element over here which is at a distance of x from the center of the rod. So what we'll do is that we'll calculate the mass of elementary element as we have been calculating in every cases. So over here what we'll have? Mass of elementary element is our mass of elementary element. See what we have? We have delta m. We know that mass per unit length is how much? This is m by L, and our element is delta x, let us suppose. So mass of this small element will be equivalent to m by L into delta x. And we know that how to calculate the moment of inertia. This is moment of inertia is basically delta m into x square, and it goes from where to where? See, this is the origin. So this side is going to be minus L by 2, this is L by 2. So this is L by 2, this is L by 2. What do we have? Delta m is m by L, this is x square delta x. And what do we have? This is minus L by 2, this is L by 2. Again integrating it out, what do we get? This is x square integration x to power 2 plus 1 upon 2 plus 1. It goes from minus L by 2 to L by 2. What we'll do is that we will place the values over here. It is going to be what? This is L by 2 whole cube minus L by 2 whole cube. So what we get? This is m by 3L. This is what? L cube by 8. This is minus plus. This is L cube by 8. Then we have, this is m by 3L. This is what? 2L cube by 8. This is coming out to be what? ml square by 12. This is the moment of inertia of rod which passes through the center of mass. Now what we'll do is that we'll calculate the one cases. That is that if the axis passes through one of the end of the rod. What is that? In special case, moment of inertia of rod about axis passing through one end of rod. See, what we'll do is that, see, we'll apply, this is the new axis, let us suppose, and we already know that when it was passing through the center of mass, it had moment of inertia ml square by 12. So, moment of inertia along the CD will be equivalent to what? This is moment of inertia along the AB plus m into h square. So, what do we have? Moment of inertia which passes through the center of mass was equivalent to ml square by 12. We have calculated it out over here. This is ml square by 12. And what do we have? This distance is L by 2. When we apply the parallel axis theorem, it is m into L square by 4. When we take it out, it is coming out to be what? This is ml square. This is 3ml square. It is going to be what? ml square by 3. This is the moment of inertia of rod which passes through one end of the rod. This is all about, there are numerous cases, like we have a sphere and all, but over there what you need to do is that we can learn the formula and we can solve the numerical. These are the basic derivation based on the moment of inertia, that was ring, disc and rod, which comes to class 11's syllabus very frequently. That's all for today. We'll meet in the next class. Thank you.